Okay, let's have a real quick look at this. I want to go through one of these guys. I don't feel like this, because and then everybody, close what you're doing. You can get back to it, but I want to see all those down close. I want everybody's attention up here, because I'm going to show you something that you're going to have to do on the next steps. Most of the tests will be this. And I feel like we're kind of at square one on this, which is fine. But I want you to get some practice immediately so you learn this, and then you can go on and do what you need to do. All right, so a problem like this, we're supposed to find all the real zeros. They don't give us anything, right? So this looks like a problem we would have had like a week or more ago, right? Where we've got a 4-term polynomial and we're trying to factor this thing. It's not going to work though. If we try to factor this, you could try it, but it's not going to work. If I split this, there's nothing I can factor out. There's no GCF. If I split this down the middle, what's my greatest common factor from the first group? Which is going to leave us with what? 2x minus 3. Okay, so now if we look at the other group, there's no way that's ever going to work out, right? You might say, okay, well, let's try this. What times 2x is negative 14x? Negative 7. But look what happens when we distribute that. So negative 7 times 2x, negative 14x, check. Negative 7x times negative 3. Whoops, didn't work, did it? Right? So grouping is not going to work. Okay? It would have been okay to try that, but it's not going to work. Does everybody see the shortcut, how we could tell it's not going to work? If you look at the coefficients, 2 divided by 3 is not equal to 14 divided by 15. That's one quick way to kind of see if grouping might work. That would have to be true for it to work. Okay, I want all the earbuds and stuff away, please, while I'm doing this. So what do we do then? Okay, so this is the thing I was showing you. You guys, it was day before yesterday. We went through this on Monday. So now we've got to do the rational root theorem. We've got to see if we can find a zero that we can divide out, right? If we can divide 1 0 out, we're home free, because this is only cubic. So if I can find one of the zeros and therefore a factor, this thing is going to split apart into that 1 0, and then the other thing will be quadratic. And that's easy to solve. So, but we got to find one of them. So what are my choices? Remember that the way we do this is they're going to be fractions. The answers, the values of x we could try, are going to have to be fractions where the numerator is going to be a factor of the constant and the denominator is going to be a factor of the leading coefficient, right? So what are the factors of the constant of 15? 1, let's go from smallest to biggest. 1, 3, 5, and 15. That's it, right? Factors of 2 would just be 1 and 2, and we could take the plus or minus of each of those, right? So then that means that our answers are going to have to look like this. X is going to have to equal some fraction where the top is going to be either plus or minus 1, plus or minus 3, plus or minus 5, or plus or minus 15. I'll just leave the plus or minuses off on the bottom because we don't really need them. We've already got the signs. We know the signs could be either one. So the bottom would either just be a 1 or a 2, right? That's a lot of choices, but dividing the ones with the 2 on the bottom are going to be hard, right? Those are fractions. They're going to be harder. We would always start with the integers, and I'm always going to make it work out so it's an integer. I mean, if they're dividing fractions through synthetically, is a little harder to do. We're not going to do it. We're just not going to do it, right? So we know it's going to be a 1 if it works. So all we have to do is just try those possibilities. Let's make a list. These are the x values we're going to try. So we've got x could be 1, negative 1, 3, negative 3, 5, negative 5, 15, negative 15, and then if we kept going, there would be the ones with the 2 on the bottom also. So we could also get 1/2, negative 1/2, 3/2, negative 3/2, etc. But we're always going to try these first anyway, right? Does that make sense? Everybody get that part, because that's important, right? What are the possible x values you could try? Look at the factors of the constant, right? factors of the constant divided by the factors of the leading coefficient. But the factors of the constant are going to be the integer possibilities that we'll try first anyway, right? Okay, so then we would just make that little template like we were the other day. We're just going to, here are my zeros. 2, -3, -14, 15. And now we'll just go down the list and see which ones work. I'm going to go ahead and make a little line right there because this is where the 0 would show up, right? Consider that to be like our box. And then we'll just go out front and we'll try some values. Like I'll try 1, see if 1 works. So I bring down the 2, right? I always start by bringing down the first digit. 1 times 2 is what? 2 plus -3? -1. -1 times 1 is -1 plus -14. 1 times -15 is -15 plus 15 is 0, so it worked, right? Well, what if it hadn't worked though? Well, then I would have just crossed that row off and gone to another one, right? See what I'm saying? So the fact that it worked, okay, that's good. That means that we found we're supposed to list all of the real zeros. Well, there's one of them. 1 worked, right? So now we got to find the other ones. Well, the other ones are just going to come from this, right? So this is the box. That's the remainder box, which is 0. What is this telling us? What's the other polynomial factor? Okay, I'm seeing, put those lids down. Everybody put your lid down on your Chromebook. Everyone's got to see this. Put it down, Trev. So what is this telling us? That's the constant coefficient of x squared, right? So then what we're left with is the smaller polynomial, and I just have to find the zeros of that one. But that's easy, it's quadratic. We did 1 billion of those back in Module 3. I could try to factor it, but because it's got a 2 in front of the x squared, don't even bother. Just use the quadratic formula. In fact, if you look at those numbers right there, tell me, if I use the quadratic formula, what's my value of a and b and c in this quadratic equation? What's a? 2. What do you know? There's a. What's b? Well, coefficient. -1. Hey, what do you know? There's b. What's c? How about that? So really, I could even just put those numbers in the quadratic formula if I want to, right? See what I'm saying? So then we would just get if I do the quadratic formula, then I'm just going to get x equals -b. What's that? Plus 1, plus or minus the square root of
1.
-1 squared is 1 minus 4 times a times b, which is -15, all divided by 2 times 2 is 4, right? Well, what are we going to get in here? Let's just figure out what this number is going to be. What's -4 times 2 times well, what's 2 times -15?
30.
-30 times -4.
120.
120, right? Good. Plus 1? 121. So all this stuff in here is the square root of 121. What's that? 11. So that's 11, right? So then the quadratic formula is just going to become 1 plus or minus 11 over 4. So I just do the plus. If I do the plus, x would be 1 plus 11 is 12, divided by 4 is what? 3. If I do the minus, I'd get 1 minus 11 is what? -10, good, over 4, so x would equal -10 fourths, which reduces to what? -5/2. So there's an answer that we'll add to our list up here. There it is. Okay, right? But the part that's different is this part. You got to be able to make a list of possible x values and plug those in until you get a hit, right? And then you know that's a 0. And so now I can use, notice what I did. Then I went down, this is my new list, isn't it? Right, there's my new list of coefficients, and I just work down from there. If I need to, right? But in this case, it was quadratic, so I'm done. Okay, got it? Go. You gotta do 7-1 though. I wanna see at least one problem done on 7-1. Yeah.
Okay, so where you put 1, would it be -1 because it needs a 0?
No, the 0 was the number that goes in there,
Oh, well, yeah.
right? You're thinking of what's the factor that goes with that? The x minus 1.
Oh, okay.
Right.
Oh,
Okay, how about it?